In the following examples, we're asked to solve the quadratic equations by completing the square. If you are unfamiliar with the method of completing the square, we recommend you watch the first videos on that topic in this series. So, for our first example, we have x squared plus 4x plus 4 is equal to 0. If we complete the square, this gives us x plus half the coefficient of the x term, which is 2, all squared, plus the 4 we had originally, subtract the square of the constant term in the brackets, which is 2 squared, which is 4, equals 0. And so, we have x plus 2 all squared is equal to 0, since the 4's cancel. And so, x is equal to negative 2. For the second example, we have 2x squared minus 6x plus 1 equals 0. That implies that x squared minus 3x plus 1 half is equal to 0. Here, we've just divided both sides by 2. And now we can complete the square. X minus 3 over 2 squared plus 1 half minus 9 over 4 is equal to 0, which gives x minus 3 over 2 all squared is equal to 7 over 4. So, x minus 3 over 2 is equal to the square root of 7 over 4. And remember, we can have the positive or negative square root, so that x is equal to 3 over 2 plus or minus the square root of 7 over 4. We can rewrite that as x is 3 plus root 7 over 2, or x is 3 minus root 7 over 2. For our final example, we have some rearrangement to do first. If we take away the right hand side from the left hand side, that gives us 3 plus 8x negative 2x squared is equal to 0. Now we're going to take out a common factor of negative 2 and divide each side by that negative 2 to give x squared negative 4x negative 3 over 2 is equal to 0. Now we complete the square. X minus half of negative 4 is negative 2 squared, minus the 3 over 2, and subtract negative 2 squared, which is 4, equals 0, which gives that x minus 2 all squared is equal to 11 over 2. And so, x is equal to 2 plus or minus the square root of 11 over 2, which, if we want for neatness, we can rewrite as x is 4 plus the square root of 22 over 2, or x is 4 minus the square root of 22 over 2.